Good evening, everyone. Hope you are doing well. This evening, we are going to learn about ANOVA, analysis of variance, how, when to do ANOVA. First of all, please go and subscribe to our channel, which can allow you to have further video when we be uploading them. Okay, what is ANOVA? ANOVA is done when we want to compare more than two group means. Okay, I'm precisely more than two group means because if you have only two groups, you can use t-test to do the same thing. But t-test you can use only two groups. But now when you have more than two groups, you can go to ANOVA to compare means of groups. And not only that one, also it can allow to see the impact of the independent categorical variable on the dependent variable. We have two kinds of ANOVA one way, ANOVA two way. And what's the difference between them? ANOVA one way and ANOVA two way. The difference is just the number of the categorical variables we have. Like for ANOVA one way, we have only one categorical variable, and ANOVA two way, we have two categorical variables. Okay. And now the dependent variable when we are running ANOVA should be quantitative one. The independent variable should be categorical when in the case of one way, and two categorical variables in the case of two ANOVA. The first example we are going to talk about is ANOVA one way. As you can see, we have salary and we have group one, we have salary group two, salary group three. Then here we want to compare the means of those groups, like the salary of group one, salary of group two, salary of group three. We want to compare to see if the means is the same or it is statistically different. So this is we are doing ANOVA. And before to do that, to allow you to execute or to run it in the software, you need to arrange it in the sense that you have only one quantitative variable, which is salary here, and the other side group. Then we have to group those groups. So this is becoming categorical variable. Have group one, group two, and group three. Have the salaries there. And I have to remind that this video especially we will be using three software. First of all, we'll be using STATA and see how those kind of things are done in STATA. After we use R, after we can use SPSS. And whatever the software you are using, you can learn how those kind of things are done. That is, and now as I was just saying, ANOVA two way is performed with one quantitative variable and now two categorical independent variables. Okay, I have already talked about the differences. It's the number of categorical variables. Now, as example for ANOVA two way, we have now, as you can see, we have salary here, which is quantitative data. We have group one, and now we have also gender, which is binary, and which also we can classify as categorical one. And we have salary group two, and now gender, which is group three and three. And we can arrange our data to be like what we have also here. We have salary, and now the first category variable 1, 1, 1, 2, 2, 2, 2, and the second one 0, 1, 0, 1, and so on. And then if we dispose or we make our data this structure, we can use software to do ANOVA and so on. Okay, then as statistical tests, always we have what we are calling null hypothesis, and we have what we are calling also alternative one. And now the null hypothesis for ANOVA is here because we have three groups. The three groups have the same means of salaries, and now the means of the different groups are statistically different. And we will be accepting or rejecting null hypothesis according to the value of the result, according to the value of the result. Okay, now what however ANOVA is showing us is to tell us if those tests or those groups we are comparing are the same or not. But to see how this difference is, we need to do some post-tests. And now we have many post-tests. And we are choosing the post-tests according to the structure of our data. Some can just tell you that after ANOVA, they are using TAC because the literature review is saying that it's the widely used. But it's not enough. We should understand the structure of our data before to decide which kind of posters we should be performing. As you can see, let me show you something. Can you see what is happening here? Okay, we should be sure, for example, that we are asking ourselves about our data. The groups we want to compare, are they having the equal variances? If yes, we should ask now, are they having the same number of observations? If yes, at the same at this time, you can decide to use TACI test or REGWQ. But if we are asking ourselves, are they having the equal variance? Yes, but here we can realize that the number of observation is not the same. And at that moment, you can ask again if the difference is slight or is a huge difference. If, for example, we have for the first group, we have 6 observation, the second group 7 observation, the third one you have like 7 again or 8. That means that the difference is not big. We can use Gabriel test. But if the difference is big, huge, like the first group 6 observation, the second one 20, the third one 50, then the difference is big. We can use now Ashberg test as post test. But if the first question we are asking ourselves equal variance in the end, we can realize that there is no equal variances. Then at that moment, the post test which is advised is this one, Games Howell post test. That is what I wanted to show you. Then let's go back there. After that, what we have to report is the brief description about the dependent variables and also the overall F value of ANOVA, and now the result of the post test. Then let's go in the practical way. We will go first of all in STATA, we do that, and after we will go in SPSS, and we will close with software. Then coming to STATA, I have already my data there. Let me show you it. I have salaries and I have group 1, 1, 1, 2, 2, 3, 3, and I have also gender 0, 1, and so on. But what is happening there? Then now I have my data and STATA. I can now perform my ANOVA test. Let's start with ANOVA one way. Then what I have just to write ANOVA, and now the quantitative variable, which is the dependent one, salary, and now group, and I can run, and I have the result. Okay, what's the meaning of what we have here as result? First of all, as we can see, the model and also the group are significant, statistical significant. They are less than 5%. And here, what we can say that group has an impact on our dependent variable. Group has an impact on our salary, and also there is difference. There is differences among those means of group. Group 1, Group 2, Group 3. The means of the salary are different. It's for this reason significant. If it was not significant, that means that the means of Group 1, Group 2, Group 3 are the same. Okay, that is. And now that's one way to go with ANOVA. One way. You can also use this command. One way, salary group, and do the same thing. And you can see that the result is the same one we have also around that here also. But only this one is reporting also the test, chi-square test, which can allow us to know that our groups have the same variance or variances or not. As we can see, the p-value of the chi-square here is greater than 5%, meaning that we have equal variances among the group we are comparing. That is, then you know already that to use the post test, we have said we said yes for equal variances. We should now ask ourselves the number of observations are the same or not. That's the second question we should ask ourselves before to decide which kind of test will be performing. And now let's go again in our data and see. Group 1, 1, 2, 3, 4, 5, 6, 7, 8. Group 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have also the same number of observations, meaning that it can allow us to use TACI test. Okay, yeah. Then let's go now and perform that test. Okay, I want to start this ANOVA. And wait, okay, and now I can do my test. Okay. Okay. How target test or post test is done? Okay, I have to present that we are doing it when it is significant. When the significance is then as there is difference, and now the test can allow us to see how groups are, means of groups are different from each other. Then what can you see now? The command is BW, mean salary, and now over group, because it's the group here we are using, and the mean comparison target effect. And I can perform it, I can run it, and I have the result. And first of all, what can I say? A group is composed of three. One group, two group, three. And now we have just to go and see what the value of our p-value. As we can see, the first one and the second one are significant, meaning that they are less than 5% in this case, meaning that the mean of group 2 is statistically different to the mean of group 1. And now the mean of group 3 is statistically different to the one of group 1. But here we can see that the third one is not statistically different. Then we are accepting it, saying that the mean of group 3 equal the mean of the group 2. Now those ones which are different, that's the difference of the mean set, which is given here. In that way, we are doing ANOVA 1 when we are STATA. Okay, to do ANOVA 2 is the same thing, only that we are adding another variable. We are adding gender, for example, here. Let us do that here. Then to do ANOVA 2 I have just to write ANOVA, the quantitative variable group, and now the second categorical variable. We said previously that the difference between ANOVA 1 2 is the number of categorical variables we have. Then ANOVA 2 is performed with two categorical variables. Then I'm just bringing them here, group and gender. And now I can run, and I have my result. As you can see, the result of the model is reported, and also the result of group and gender. And here we can realize that it's only gender, a group which is statistically different, because the p-value of this one is greater than less than 5%. But for the gender, it's greater than 5%, meaning that it's not statistical, it's not significant. Then even if you want to do post-test again here, we will consider only group, because it's the one which is significant around here. Then the post-test we did previously is the one we will do also here again. Okay. This one, and we will be having also the same conclusion. Among this group now, we have group 2 and group 1, which is different. That's called different because can you see they are significant, and the group 3, group 1 also, which are statistically different because the p-value also is another 5%. That is, but we can perform also the one for gender and see, and we will see that. Well, we don't need to do that, but we can do it and see what it present, why, what is presenting us as a result. Yeah, this one we just put in the same thing, only that on here we will change group by gender because we want to do it with gender. Now we have this one. Can you see the p-value is greater than 5%? Then we are, can you see, it's not a significant, it's greater than 5%. Then we are doing what? We are accepting H note, which is saying that the group, the mean of group 1, which is the number of male here, and the mean of group 2 are the same. That is, we are accepting H note. We fail to reject H note because it's not significant. That is, yeah. I want to show you again something there. Okay, when doing ANOVA, and we want also to see the interaction. Yeah, what's the impact of the two groups put together, interaction of the two categorical variables? We can add this one. And can you see, we have group, we have gender, and we have now the interaction also. But unfortunately, the interaction also is not significant. Yeah, can you see? But when you want to see not only the one for the categorical variable individual, you want to see the interaction, the impact of the interaction of the dependent variable, you can use dash and have this one. Okay, it's how it is done in STATA here. We can now proceed with SPSS and see what is happening here. I'm here in SPSS. You can see how the data look like. Can you see? Okay, we have salary, group, gender, so on. And can you see the structure? Yeah, nominal, quantitative, one scale. Okay, then we can do something around here. When we want to do ANOVA in SPSS here, we have there to do right? Since we are comparing means, we can come here, compare means and ANOVA one way, and come here. Now, boom, let me bring them back and see, yeah, how normally it should be. It should be like this. And now I should be putting my dependent variable here, which is salary. Go in there. And now here, we choose one way, and we can now take group and put it here. And now we want the result to come with the post text immediately. We can go here. And now, as I was just telling you, we have many post texts, but according to the structure of your data, you can use. And here we have already realized that we have the same variances, the same number of observations, then we can use TACI. So according to this one, this rule, same variance, same number of observations, you can use TACI or RETWQ. Okay. Yeah. Now I can take my TACI and now continue and now validate. Okay, we have our results. Can you see ANOVA is coming and the significance? The significance here of ANOVA is telling us that effectively there is differences among those means we are comparing. And also this group now has effect on the dependent variable. And now the post test is coming here on the same as the one in the STATA. Can you see the group 1 against group 2 are significant, meaning that the means of the two groups are statistically different. Okay, and the same thing group 1 and group 3. But group 2 and group 1 also is significant. Just the same thing 1, 2, or 2, 1. But now group 2 and group 3 is not significant. And we see this value is greater than 5%. 3 and 1 significant. 2 and 2 as the same case here are not significant. Okay, when it's significant, we are saying that effectively we are rejecting H note and saying that there is statistical difference between the means of the two groups. But when it's not significant, we are saying that we fail to reject H note and saying that we have the same. There is no statistical difference among them. That is, and you can see how it is done also in SPSS. You see, we have the same figures, only that here the structure of the results is different, but we have the same figures. That is. Let us move to R, the R software around here. Okay. I want first of all to show you how the data is coming to look like. It can look like around here. How to proceed. As you can see also, when we brought data here, we have salaries, we have group, we have gender. Okay, then we can proceed with our ANOVA test. And now regression ANOVA, what we need to do just around here is what is we need now to okay. Remind the data we are using data equal this one, and now the quantitative data, and now the group and gender. Okay, as you can see, sometimes when you are bringing data inside R, you have those ones you want to be categorical, or those ones which are categorical. You have to remind R that they are categorical, and R is using this is using factor to call categorical variables. Then you have to say as factor, okay, because we want our group to be a categorical variable here, and gender as factor, we want it to be categorical variable. Can you see? And now I can use also plus, but I use here the star or the multiplication sign because I want to bring it again to see what's the impact of all those category variables being together. For this reason, I'm using star there. Now I can run. Okay, it's run. And now it's not yet finished. You should write ANOVA and bring this one there, the brackets. Now that one you can see the details. As we can see, we have group, we have gender, we have the interaction of them. But from here, we can see that it's only group which is significant. R also is helping to show those variables which are significant, bringing stars. Wherever we will see stars behind 1 or 2 or 3, that means that the variable is significant. There's only group which is significant, gender is not significant, factor also, and gender together, the interaction is not significant. But at least one is significant. We can do Taki HSD test. As I said just before, we have the same variance, the same number of observation. We can allow us ourselves to take the post-test Taki, and now we can just do it. Okay. Okay, let us to bring us results and see what is happening now with the Taki test bomb. What we know is, or we should know, is we should be having the same result, only that structure is different. Can we see it take a variable by variable, the group, for example, now it's significant and telling us the group, the mean of group 2 and group 1 is significant. Can you see the p-value is less than 5%? The group mean of group 3 and group 1 is significant, less than 5%. But the group 3 and group 3 are not significant. The same result we are getting for others as well. But when we are taking for gender, it's not significant. Can you see the p-value is greater than 5%? And now the conclusion here is the mean of the number of male and number of female is the same. And now it's bringing this one because we are just also having the interaction of factor and group and gender, that is. And also is how it's done here in R. And if we want to do like one way ANOVA around here, we should be having only one factor rather than two. We will have the same result also. That is, hope that this video will help you when you will be performing your test and so on. Okay, don't forget to subscribe to the channel. This one will allow you to get a future video. Just subscribe down there, the red button, click and activate the notification bell, which can give you a message telling you what we have in the video. Okay, thank you so much and have a good night.